So we're going to finish up chapter 2 today. We're going to talk about finding values from areas. So yesterday, the last 2 days actually, we've been finding areas from values. Now we're going to go backwards. Okay, so we're going to go backwards. All right, I promise you this is the last day that we're going to look at this example of this ITBS score thing from Gary, Indiana. But the ITBS scores from Gary, Indiana, same distribution that we've been doing all week. Normal distribution has a mean of 6.84 and a standard deviation of 1.55. All right, what score would a student have to earn to be at the 90th percentile of the distribution? Okay, so basically here's what we're asking. With this distribution that we have, knowing that there's 90% of the data shaded below this score, what is the score? Okay, obviously we know we're higher than the 50th percentile, so we know we're higher than the mean. Also, do you guys remember what percent of the data is from the mean to one standard deviation above the mean? What percent is in there? That's 34%. So if I know there's 50%, below the mean, plus 34%, that's 84%. So I would have to go a little further than this 8.39. But how much further? Well, enough to make up to the 90%. So I need 6% more. But what value is that? So that's what we're trying to find out. So what we know is that we know that the area from the value down is 90% because there's 90% below the value. And so we need to find the actual number, okay? So we're going backwards. So this is going to require us to use an inverse of what we've been doing, okay? So to get the score, we're going to use the normal curve but in reverse. And that is called the inverse in math. So if you guys will thank your calculator, it's going to do it for you. All right? I love this calculator. It's so great. Everybody go to second VARS. But don't go to normal CDF. Look right below normal CDF. What do you see? Inverse norm. Inverse norm. So inverse norm, if you click on inverse norm, for those of you who see the inputs, perfect. For those of you who don't, I'm going to fix that today, right after we're finished. But this is what we're looking for. The area. Now, this area has to be the area below whatever it is that you're looking for. And then the mean of the distribution and the standard deviation of the distribution. Okay? So that's what we're going to use. It does have to be the percentile area, so the area below the boundary. For those of you who have fancier calculators, it's asking you what tail, left, center, or right. You're going to always say left. So let's do it. We've got this distribution. It's the same distribution as always. We're going to plug in inverse norm. Our area, it needs to be as a decimal. So 0.9. The mean of this distribution is 6.84. The standard deviation is 1.55. Those of you whose calculator is not updated just yet, you're going to just put in 0.9, comma, 6.84, comma, and 1.55. When you plug this in, this is going to give you the boundary that cuts off that lower 90%. Again, those of you who have the little bit of a fancier calculators, you're saying left tail. Now, we know that this number should be somewhere above 8.39 because we know that the boundary is above 8.39. And so what'd you guys get?
8.82.
Boom, 8.82. Does that make sense?
Yes.
Absolutely. That makes sense in terms of our distribution here, okay? So that's how we find a value that cuts off an area, 8.82. Now, I want to tell you, you can also find the z-score associated with this by using a value from the standard normal distribution. So if I do the area of 0.9, but I use 0 and 1, which is the standard normal distribution's mean and standard deviation, then I would get the the z-score that is associated with that same cutoff. And it was on here somewhere. There it is, 1.28. So now I know that this value that cuts off the lower 90% is 1.28 standard units above the mean. Okay? Any questions about this? All right, let's do another example. Or actually, here's the instructions. Draw a normal distribution, label your axes with the mean and the standard deviation, use your calculator to find the unknown value, get the z-score if you need it, and make sure you answer the question that was asked. All right, cool. Here we go. Here's the automobile question, same question that we've been working with this week. Many studies on automobile safety suggest that when automobile drivers must make emergency stops, the stopping distance can be modeled by the normal distribution. Suppose that for one model of car traveling 60 miles per hour under typical conditions on dry pavement, the mean stopping distance is 165, standard deviation is 4. 1% of all such emergency stops take more than what distance? Okay, so we got to be careful here. The first thing is we want to draw the distribution. So everybody needs to draw the distribution and label the mean and the standard deviation. The mean is 165. The standard deviation is 4. So we've got our mean and our standard deviations labeled. All right, now let's think about what this question is asking us. It's asking us, it says 1% of these emergency stops take more than what distance? Okay, so really what it's asking us is what value cuts off the top 1%? But we need it in percentile. So if it cuts off the top 1%, then what does it cut off below that? 99%. Perfect. Very, very good. So the top area is 0.01 or 1%. But we're looking for the number that cuts off the lower 99%, which is the same number. Okay? So just again, to be clear, the percent that you put in or the decimal you put into your area in your calculator has to be the lower area. So we're going to put in a lower area of 0.99 when we do this problem. Okay? Hang on, it's still on you. There it is. There it is. So we're going to go to inverse norm. Second vars, third option down, inverse norm. The area we need to put in is the lower percentile area of 0.99. The mean of this distribution is 165. The standard deviation is 4. For those of you who do not have an updated calculator, you're putting in 0.99, comma, 165, comma, and 4. And I'll update your calculator in just a minute. Because of the fact that you guys know the percentages, you can already tell that it's going to be way up there between 173 and 177. So that your answer should be between 173 and 177. And what did you get? Boom, there it is. And let's say we need the z-score associated with this. Same thing goes in for the area, but what would your mean be? 0. What would your standard deviation be? 1. So the z-score associated with this value would be 2.33. So that means that 174 miles per hour, 174 feet of stopping distance is 2.33 standard units above average. Any questions about that? All right. We just have one last little example here, and then we will be done. It's the cholesterol question. High levels of cholesterol in the blood increase the risk of heart disease for teenage boys. The distribution of cholesterol is approximately normal with a mean of 151 milligrams of cholesterol per deciliter of blood, and standard deviation is 25. We need to find the 20th percentile of the distribution of blood cholesterol for teen boys. We're going to find the Z-score associated with that value, and then we're going to talk about teenage girls. Okay, good times, because we're equal here at McKinney Boyd High School. We talk about the boys and the girls. I can't get there again. There it is. All right.
Look at the board.
So, look at the board. I'm looking at the board.
It went away as soon as you looked at it.
What was it?
It was like messed up.
Okay. All right. Did you guys find the answer already?
Yeah.
All right. Did you do inverse norm? What area did you use? 0.2. Very good. What mean?
151.6.
What standard deviation? 25. Cool. And then what did you find was the 20th percentile? 130.56?
Yeah, sure.
Perfect. Okay. And you guys, did you find the Z-score associated with that? Okay. How do you do the Z-score associated with this? Same area. What do you put in for the mean? 0. What do you put in for standard deviation? 1. And you'll get the Z-score associated with this 20th percentile. It should be below the mean. Should be below the mean. So it should be negative. And what did you get for your Z-score? Say it again. Oh, how do I know it's negative? So the area is 20% below this number. The mean is 50%. So I know I haven't gotten to the mean yet. So I know I'm below the mean. So how many standard deviations below the mean? This is 0 and 1 for this question. Negative 1 point what? Negative 184? Oh, negative 0.84. My bad. Negative 0.84. Okay. Teenage girls. They have a mean of 157.5 and a standard deviation of 22. And what is the top 5% cholesterol level for a teen girl? What are you guys going to plug in to inverse norm? If we're looking for the top 5%, what are we going to plug in for the area? 0.95. It has to be the lower area. So 0.95. Now this is the mean for the teenage girls. So 157.5, standard deviation is 22. This is going to be the value that cuts off the top 5%, which is the bottom 95. And what did you get? 193.69. Okay, perfect. And what's the Z-score associated with that? Leave the area the same, 0.95. Your mean is 0. Standard deviation is 1. This should be a positive number because I am above the mean this time. I'm above the mean, so this should be a positive number. What'd you get? 1.64? Anybody else get that?
Yeah.
Okay. What questions do you guys have? Perfect.